Myself Birendra. Today I am going to teach you basically MOSFET. You know very well MOSFET is the heart of power electronics. Without MOSFET we can't think about DC converter and inverter. You know very well. In daily of life you are using inverter. Inside the inverter there is MOSFET are there. Basically all the converter losses are depend upon MOSFET basically. MOSFET or otherwise we can say other switch IGBT. That's why it is very important topic of MOSFET as a respective of power electronics engineer. Nowadays there is big problem in switching losses are there and conduction loss are there. We can reduce the switching losses. We try to optimize the switching losses. There is research part, but I will explain basic topic of power electronics. Basically, I will explain turn on, turn off characteristics of MOSFET, and I will find the switching losses also. Okay. Basically, I have taken some reference are there. I will explain later. But suppose that we need to start turn on the MOSFET. We need we need to apply the gate to source voltage above the threshold. Above the threshold, we can say our MOSFET will be turned on. How to turn on? I will explain later. Basically, to turn on the MOSFET, we need to VGS voltage apply from here to here, gate to drain, gate to source. Suppose that. Basically, this is the VGS voltage. This is plateau. This is threshold voltage. Suppose that when we are applying gate to source voltage here, when this voltage is crosses the threshold voltage, then drain current. Drain current. Suppose that this is a ID. Drain current will start to turn on. How to turn on? We can see when gate voltage is above the threshold voltage, then our MOSFET will be slowly turned on up to when apply the gate to source voltage plateau voltage. When reach the plateau voltage, then our MOSFET gain drain current will reach maximum value. Suppose that this is maximum, it reaches here. Then this is the ID max. After that, our try to this is the drain to source voltage. This is VDD. Sorry, VDD. VDS across the MOSFET. When the MOSFET will turn on, then we know very well that this is short circuit. Then uh, this is drain to source. When it's short circuit, then across the MOSFET in IDD is zero voltage. Practically not voltage because of I into RDS on resistors are there and some drop are there. And this time, this is called delay time. This delay time depend upon the input capacitor of MOSFET to suppose that this is gate resistance, this is CGD, CGS. Basically, delay time will take to charge the MOSFET input capacitor. Here we can see there to charge the input capacitor, it will take time. TD. We know very well in RC circuit. I will explain later how to suppose that this is delay will take time T1, and I will this is T2. Suppose that we need to find the rise time, then we find T2 minus T1, we will get T rise time. Okay, I will explain in next slide. Okay, I will explain here. Don't worry. Basically, we know. Basically, it is a basically RC circuit. This is R. This is RG, CGS, CGD. Here I am considering VG, VGS. Sorry, VG, VGS here. I am considering. We know very well the RC circuit. Suppose that this is RC. Basically, this is RC circuit. I am writing the direct formula here. We know very well charge capacitor formula is VC, VDC. Sorry, 1 minus e to power t minus tau. Here tau is the CGS plus CGD. I need to find out the rise time. I will explain. Find the rise time. The VC, VCT I am taking here. There is VGS, VGD. Sorry for that. We know very well the here is VGS, VGD 1 minus T by tau, VGS into VGD into 1 minus T by tau. I am taking by this one. VGS is equal to sorry, I am writing here T is equal to RG. C is the total capacitor. Suppose that I am taking C total is equal to CGS plus CGD. Otherwise, we can say CSS input capacitor. ln 1 minus VGS into VGS. Suppose that we need to find out this delay time. Then during the delay time, there is final value is threshold value. VGS initial VGS value is VGS. Final value is threshold value. We can put here directly VGS. How much VGS value here? Basically, it is going to be minus the threshold value VGS. This is T1. Like T2, we can find CG, CSS, LN. Here, 1 minus, sorry. CS. Because of this VGS value is uh, getting the here value. This is we can easily find out delay time and write time. Basically, I am going to explain about basics of these unknown characteristics. I will explain here. Suppose that this is threshold voltage over the current will start. VDS into this is IDS. I will try to find the switch on losses here. Basically, this is delay time. This is delay time. Basically, delay time depend upon the capacitor. If capacitor is more, then delay will take time, more time. Delay will be more because we need to we need to more time to charge the capacitor. Input capacitor or MOSFET. That's why we doesn't need to take more time to turn on the MOSFET. Otherwise, our switching time will be less. We cannot switch fast in any application. Here, this is suppose that I am considering T1 and suppose that T2 and here is T3. Power loss. This suppose that this is drain current, this is drain source, drain to source voltage, then total power loss. We know very well. This is the area. Under the area, we'll give the switching losses because of we know very well power is equal to VI. This is instantaneous. Then I will consider this form. We know very well the formula switching power loss. This area formula is total base into height. total base I will take. Suppose that in some basically in some data sheet there are given this is delay time, this is delay time and rise time. But here I am considering this. Suppose that I am considering the delay time here to here, delay time this one. But in some cases considering here to here. But in these cases T2 minus T1 is the here delay time is TD. This is delay time into rise time, right? VDS IDS into time period of delay time rise time. This is totally turn on time. We can say VDS ID into switching frequency. This is turn on power losses. I will explain in datasheet for better understanding. I will take some time. Here we can see here in this in other dataset there are given different way. Here switching losses is 1 by 2 T delay and T rise time into VDS IDS. This is plus 1 by 2 T delay T fall time VDS IDS multiply by switching frequency. Yes, switching frequency. We can directly find out 1 by 2 turn on plus turn off VDS IDS switching frequency. This is the switching losses. We can see there this is delay time, rise time are given in the datasheet. We can see here there are given. We can directly here find out VDS 50 into IDS 70 into rise time delay delay on time 11 rise time 40 switch frequency also given. All the data given. Turn on delay time, rise time, fall time, all given. We can find the power switching power losses. There is given directly. Basically, when you are choosing the MOSFET, there are depend upon voltage across VDS, reverse voltage. We can see here 100 volt. Here VGS at VGS 10 voltage. RDS on is here. Basically, we know very well you are increasing the gate gate to source voltage, then conduction will be more. Basically, electron will be more attracted to gate side, then RDS on will be reduced. That's why it is given at a particular value of RDS on. There is Q gate voltage given, gate to source voltage given, to gate to drain voltage charge are given. Basically, this capacitor is more compared to this one. We can easily see. Look here. In other day, I will explain all this thing. This is I have already explained it, these parameters. This is my first video. That's why I am not explaining properly. Okay, thank you. If any doubt, you can ask me.